tapered off. So right now, the current rate of sea level rise is about 1 millimeter a year from 8,000 years ago. That is through a slope of this line, and that's what it comes out to be. If you're a little bit more careful and you look at the data with higher resolution, over the last 120 years or so, you're able to draw the line with more accuracy. You see a 2 millimeter per year rise. What's 2 millimeters a year is the rise in sea level. Right? This is 1 millimeter, folks. This is my Kroger card. It's 1 millimeter. Okay? So double this up, double this, and this is now the yearly rate of rise of the sea. Are you concerned about this? I'm not. Well, these guys, don't worry about it. They'll be fine. They're out there having a good time. They're floating around their honey. So if it's not anthropogenic greenhouse gases, then what is causing warming? What is it? Not coming to nature. We have what's called the Pacific Decadal Oscillator. The Pacific Decadal Oscillator is an ocean atmospheric circulation system. It has a cycle of about 30 years. And the El Nino Southern Oscillator, which we call El Nino, has a cycle of about 37 years. Now, the PDO, or the Pacific Decadal Oscillator, warms the Arctic and melts the ice, and it actually warms the northern Pacific Ocean. Okay? And it happened in 1977, and it happened in 1920s. Remember the quote that I just read from the National Weather Bureau? We talked about, people talk about the Northeast Passage opening up this year or last year. Well, it also opened up in 1940, at the same time that we had a PDO cycle. And here, this is the actual history of the PDO cycles. We measure the PDO cycles by measuring the rate of temperature changes in the northern Pacific Ocean. And what we see here is we see the PDO cycles from 1900 to 2000. We'll see them oscillate. We see them oscillate in 30-year cycles. So we're here about the time of World War II. We had a negative PDO cycle, which means that it gets warmer. Then we had a negative PDO cycle, a positive PDO cycle, and vice versa. So this time period here, the 1930s to 1940s, was a warm time. If you look back at the temperature records, you'll find that it was actually a lot warmer in the 1930s than it is today. Matter of fact, 1934 was the warmest year on record, not 1998. The 1930s was the warmest decade of the century, not 1990 or 2000 or whatever it's saying. And then if you remember back in the 1960s, for those of you old enough, we had a lot of cold weather. I don't know about Richmond. I lived in Michigan back in the 1960s, and it snowed and snowed and snowed. It was cold. Okay, that's because we were in a negative phase of the PDO, which means that the circulatory patterns in the ocean that influences the air, influences the global warming by changing cloud cover. Not really sure how the mechanism is. It's been hypothesized that these changes in the circulation of warm water in the northern Pacific somehow cause cloud cover changes, and the cloud cover changes cause changes in global warming because the cloud cover that exists is at the upper atmosphere, and the upper atmospheric cloud cover actually acts as a greenhouse effect and cause warming. So we can very, very easily explain temperature changes in the last century based on the PDO cycle. Now, what happened right about here we call the Great Climate Shift. This is 1978, 1976. This is when the temperature started going up again from back in the 1960s and 70s when it was snow all the time. And this is when everybody became concerned because it started to warm. Well, not only did it start to warm, but if you look at the data here, it shows that we're into another PDO cycle shift. Okay? And this is what's causing this global warming over the last 30 years. It's probably due to this Pacific Decadal Oscillator. And what's happening now, if you look at the last measurement of the PDO, it's showing that it's changing configuration, isn't it? It's starting to go negative again. And what that forecast will be is probably in another 5 years we're going to start to see temperatures falling. And the temperatures will fall probably for the next 30 years because the PDO cycle is now changing. Okay? So we can predict melt off in the Arctic. We can predict the melt off in the Arctic back in the 30s and the melt off in the Arctic today based all on the PDO cycles. Solar and orbital forces. Okay? We know that the sun is probably one of the most important contributors to global warming. When we have, the sun has a magnetic field, and that magnetic field wraps around the Earth, okay? And that magnetic field can alter the temperature on the Earth. When we have a weak magnetic field, magnetic fields tend to disrupt cosmic rays, which are always bombarding the Earth. And when cosmic rays are able to reach the Earth, they cause cloud cover. The cloud cover cools the Earth, and it causes the temperature to go down. So whenever we have weak magnetic fields in the sun, we have global cooling. Just the opposite. Whenever we have a lot of solar activity, a lot of sunspots, a lot of sunspot activity means a lot of high magnetic fields in the sun. Those magnetic fields interfere with cosmic rays. Those cosmic rays are prevented from hitting the Earth, preventing the development of high altitude cloud cover. That lack of high altitude cloud cover causes clear skies and global warming. Okay? So this is probably a very good explanation of what causes our temperature changes. And carbon dioxide, with solar forces. And here's a good experiment that demonstrates that. This was taken from a stalagmite in some cave. And they were able to cut the stalagmite up and measure the amount of O18 and carbon-14. Carbon-14 is an indicator of solar energy proxy, and O18, as we talked about before, is temperature. And if you plot the C14 and the O18, they move in sequence with one another, suggesting that as the temperatures rise, so does the solar activity. The suggestion, once again, is suggesting that solar activity is causing warming. Once again, this is a correlation. We want to be careful, right? Because correlations don't always hold up. And this is just another plot of the same thing. This is a plot of the activity of sunlight over the Arctic region and also Arctic temperatures. And you can see the red line here indicating solar activity from the sun traces very nicely with the actual temperature. Orbital forces are not going to these are changes in the Earth's orbit. There are three different types of changes that have different cycles. One of them is 10,000 for 100,000 years, 22,000 years, and 41,000 years, and they all have to do with how the Earth moves around the sun. Sometimes it moves a little bit closer to the sun than normal, and sometimes the axis tips and pushes part of the Earth closer to the sun. These all can have effects on global temperature changes because they essentially put the Earth closer to or farther away from the sun. I'm almost done. I want to say a few words about global warming arguments. Repetition of false authority. This happens all the time. You know, we hear this. Man-derived carbon emissions cause global warming, and global warming is very bad, and science is settled. And we're barraged day after day. No matter where you pick up a magazine, you turn on the TV set, and you hear this. You hear it long enough, and people that are uninformed believe it. Right? Repetition of false authority. The chain of false authority. This is very important. The IPC, which is a pretty good organization, this is a scenario that happens all the time, right? The IPCC writes a pretty good scientific report, mostly good, some not so good. The report is condensed, okay, and do an executive summary by non-scientists and political guys that skirt the science, so it's not so good anymore. Channel 6 picks up reports something from the executive summary, usually it's taken out of context. And the president of Harvard University says in a speech that global warming is escalating at an alarming pace and it's our fault. But she watches such Fox News. Well, it must be true because the president of Harvard University says so. Okay? I mean, she has authority. No, I don't want to get jammed up with the president of Harvard University. She's a nice lady, but this is just an example, right? But she's a person of authority. And when she says something like this out of context, people believe her. And this happens all the time. The IPC is considered an authority. And so people say, well, how do you believe that global warming occurs? Well, the IPC says so. You're a false authority. And so in this case, so is the president of Harvard University. You ever heard some of these? Consequences of science. The consensus of scientists say that the Earth is warming. Just look at the melting ice. So we have to control carbon dioxide emissions, and science is settled. Here's a good one. The carbon dioxide causes global warming, then the ice will melt. The ice is melting. See, carbon dioxide causes global warming. Folks, this is a fallacy of affirming the consequent. When you affirm the consequent that the ice is melting, then you also affirm the antecedent of the argument that carbon dioxide causes global warming. This is a very popular fallacy in logic that is used all the time by these people. Okay, so you should see this kind of statement, and it's in many different forms, but it basically is a fallacy of affirming the consequent. And many of the scientists that we talk about are not scientists. Out of those 4,000 people that we talked about, most of them weren't scientists. And a lot of the scientists didn't sign on. Okay, out of 2,500 scientists at the IPCC, only about 60 of them actually signed on to the conclusions of the IPCC. So when they talk about 2,000 scientists, say, no, it's more like 60, okay?